All right, so we'll go ahead and start where we were before. I do need to reopen the drainage project. It'll take me just a moment. And I'm sitting in the DRPRRD file, same exact spot that you are and had before lunch. And we'll give this another shot. So same drawing, same database. So DRPRRD01, just like you were in before lunch. And I'll reopen this drainage project and reload my preferences, and hopefully we'll be good to go. All right, so we were working with this node S200. What we had set up with it so far were the properties. That's going to be what type of inlet it is or what type of node it is. We did take a quick look at the align option. When this first came in, the top and bottom were not aligned anywhere close. That's what this align option is for. Lets you adjust, click either button until it's lined up on the right-hand side, and then click OK and it'll line those up. On the location, we learned to use this tangent to element. That was our best option there as far as how it read everything, and that allowed us to put in this offset. And also there is an option for mirror node. If this comes in out here in the pavement somewhere, that's what the mirror node option would be for. Check it on, hit apply. What it does is it flips that inlet. I'll go ahead and uncheck that and hit apply, and it'll put it back the way it should be. So what we had left off on was at the spread criteria section. So we had filled out properties, we had filled out location. And then on the spread criteria, you'll see this at the bottom of 427. This really probably isn't needed just for planned production purposes, but we'll go ahead and fill it out as shown in the book. And just keep in mind that some of these steps in the book are used when we're teaching the design class. Uses the same chapter, same exact steps and everything. So really the spread criteria here probably really isn't even needed. You'll see though, we'll still use the longitudinal slope source. That's going to be from the reference PGL. And then for the spread source, we're picking library item. And we're picking the standard lane, and it's the +2 slope. So what it's doing when it's calculating the spread is it's looking up inside of that GPK what the slope is on this profile at that station, and that's what the slope is on that PGL at that point. And then it's assuming a 12-foot lane at a 2% slope, and there's our 0.016. The ponding section down here at the bottom right, the maximum pond width here, they're using 7.5 feet. We're not designing, we're not even looking at the reports or really being concerned about the reports. But where this 7.5 number is probably coming from, I think this is a 45-mile-an-hour design speed, and the general rule is it can pond up to about half of the lane width. So that would be 6. But it's including the 1.5 feet for your gutter. That's the 7.5. So that should be good to go. Probably don't really need it for just planned production. If we go to elevations here, since we're doing at the top of 428 just the planned production portion, we're going to go ahead. We don't need the reference surface, and we're going to have an elevation source that's user supplied, and we're going to match it up here with that screenshot that we're given. So, and this would come from the drainage design that's in a spreadsheet, some other product, or maybe even handwritten or on some type of printout. So our elevation source will be user supplied, and that's going to be 31.6, and it's going to be the same for the node elevation option. It's just going to say same as source. You won't have to click anything. Once you type in 31.6 and hit tab, it's going to go ahead and update it. We're not worried about the minimum or maximum depth because we're not worried about any of the design criteria. So those are staying at 0. And then for your junction losses here in the middle of page 428, oops, didn't mean to skip past that. You can just say none, since we're just doing it for plan preparation purposes. Truthfully, it wouldn't matter what you pick here. We're ignoring the reports that come up anyway. But we'll just set it to none. That way it's not applied or used at all. Discharge options, we will have to at least plug in some type of discharge here. We're not able to compute it because we haven't assigned an area to this node. So what we're going to have to do under discharge options is we're going to put supply discharge. You can just put up, really it's a placeholder there, 0.1. That should be in CFS, not knowing what's 0.1, that's nothing. It's just a placeholder to get it to work for plan production purposes. And we'll go ahead and hit apply to save that. And then I want to take at least a couple of moments to talk about the area options. I know we're not teaching design, we're not doing design here, but usually if you take the plans preparation part, you're going to be involved in the design at some point and may design in GEOPAK drainage. So I just want to point out a couple of things on the areas. Your best bet, and I'm going to just have a blank area out here to work in. When you are designing and you're creating these nodes, unless it's an outfall or a junction, if it's inlet, it's going to have an area assigned to it. So there's a button here on the far right. It says edit area. And you're welcome to click it. We're going to end up with new zip files in a minute anyway. But if you click on edit area, it's going to say S200 is not found in the project. Shouldn't be. We didn't create it. Do you wish to create it? I'll say yes. It's going to call it the same as the node, which makes sense. I don't know why you would change that. So it's going to call it S200, but it's an area S200, not a node. And then it's going to open up this dialog box here to define the area. And unless I'm wrong here, in the area selection creation portion, I have really only found one of those 4 buttons to be understandable and useful. Is that across the board? Okay. So your best bet is to have a physical shape that you can click on. Now that shape typically would be in your DR map file. That's where you would create it. I don't think they've stored any of these in the DR map file as shapes. So that's why I went over to a blank area of the drawing. Usually, and you don't have to do this, I'm just kind of pointing out some things to watch out for. Usually that shape would be on an area called drain divides, and there's a few of those. So you have a shape, and then you do have to give it a minimum time of concentration, and then this base C value is going to be applied to whatever part of that shape doesn't have any other stuff in it that matches way back here in the drainage library these land use items. So if it's just a shape and there's nothing else inside of that shape, I pick select shape, click on it once to highlight it, second time to accept it. Now it's overwritten in red because of my settings and the preferences. It figures out that shape, and then you can go to computation, hit compute discharge, and it's going to calculate the computed discharge for that shape. Yeah, and I know that that's nowhere near that inlet. I get that. If you have inside of that shape some of these items that match the land use items, and I bet you my level filter might get me on this one. So I'm going to put something on the grass level. Which I almost went past it. So another shape. You can draw the shape manually, or you could use some of the MicroStation tools to make a complex shape. Doesn't matter how you get the shape. The main point is you want to have a shape that you can just use this button and click on it. So now if I select this overall shape and go to the sub areas, if I hit automatic delineation, that's going to pick up that shape that's on that level of grass, and it's going to assign that a C value of 0.25 or whatever the land use items have. So I don't recall what I had before for computation. I think it was 40.6. So if I go to sub areas and hit automatic delineation and click on computation and hit compute discharge again, it ought to be less. And it's 34.1. So that's where you can take advantage of those land use items. Off the top of my head, I want to say there's a building one I could use. Let's say building. I put another little shape in here. So you have an overall shape, and inside of that, you might have additional shapes. Pick the overall shape, go to sub areas, hit automatic delineation, and maybe I decide that my default C value is 0.5. So everything that is not these two shapes is going to get 0.5. The shapes are going to get whatever's in that land use. Hit compute. It ought to be a lot less than 34 now. It's 19. Does that make sense? Even if you didn't remember anything from this except don't use these other three buttons, it'll save you a lot of time. James, you've worked with it for years, I know. Okay. So, like I said, I'm not a drainage engineer. Could have been.
Others, but you have to do them in a very, very, very particular order, and if you mess up, you start over from scratch.
Yeah, these can be made to work, but the effort in making these other three buttons work is far, far greater than making a shape. So, anyway, I know we're not doing the design part, but that'll be worth you knowing at some point in time, I hope. And I'll hit undo, and we'll just undo that. Oh, let's highlight. All right, we're good. All right, so we've got this one inlet put in, this S200. If we took the spreadsheet that we see back on page 425, I believe it was, or we took this spreadsheet here on 429, and we put in all the inlet information, we would do that just exactly the same way we did this previous one. So not a lot of reason to sit here and do that and use up our time. But we do want to put here on 429, we do want to go ahead and put one outlet. And as we talked about earlier, the way GEOPAK drainage is set up is it's set up to have nodes and pipes, and those eventually run out to a single outfall that typically is a pond somewhere or a wetland area. So we're going to make one more node by going to component node, add. Now it's going to try to go to S202, and we'll just backspace over that and call it S-211, and I'm going to give it a description of outlet. And then we'll click OK. And then that's going to create a new node called S211. This is a mitered end section. It's a 30-inch mitered end section. So your node type is outlet. Library item is an MES 30 RCP 4S. You can hit the letter M. It's going to get you close. And you'll have to scroll a little bit. And the 4 is the slope. It's 4-to-1 side slopes on the end of that mitered end section. That's the angle it's going to be cut at. Physically cut the concrete pipe. And then as far as the station, we have a 706 plus 15. So we can you'll uncheck node bottom. And for your location, it can just be a point location. You can leave it tangent to element. That's fine. It ends up being 706.15, and the offset is to the right. So it's a positive 78.2. It should end up right out here. And if you leave it tangent to element, it ends up pointing the correct direction. If we didn't have an element or you just placed it by point, you can go in here and tweak the angle. And once you change the angle, you have to hit apply to see the update happen. But if you use that station and keep it tangent to element, it'll go ahead and be in the right spot there. So that area here to the right of 706, that's our pond area. And then for the elevation, we're just going to have a user supplied elevation. It ends up being 10 even. And you'll see that here at the top of 429. So we'll go ahead and click apply. And that's going to store this outlet node. And part of the way that GEOPAK Drainage builds the network and knows how to build the network is it picks up on the fact that this node type is an outlet. So it knows how to route the pipes, and they all eventually end up at the outlet here. So we just did a couple of nodes. I realized that. Everyone feel pretty confident you could take a spreadsheet or a printout. You could go in here and do more, right? It's all pretty much the same. Once you do have the 2, now you can check on window center and highlight, and you can scroll back and forth, and it'll show you where they're at. Not sure what. I messed mine up. It doesn't matter. I'm going to cheat with the zip files, but when I did that area, caused it a little bit of an issue here. That's okay. Oh, that was a 201. That was from earlier. There's my 200. We're good on that one. So if I want to delete 201, I can hit delete. Just be really, really careful. It goes to 200. You've got a little icon that you can pick and ID the node. Now it knows it's 201. That will get you every time. All right, so we'll go ahead and take a look at Chapter 5 now. Chapter 5 is the conveyance system. That is all the pieces that are carrying the water between the inlets, junction boxes, and eventually out to an outlet. I'm going to go ahead and close out of SS4. And as we talked about before, we're going to have excuse me, a network, and you will have multiple networks along most projects with GEOPAK drainage. You're going to have a network. It's going to have a certain amount of inlets, certain amount of junction boxes. They're connected with or through the conveyance system, and they're going to go to one single outfall. Then you're going to move literally a little further down the road. More inlets, more junction boxes, more pipes and conveyance system. That's going to go to another single outfall. We do have other software such as Hasted that does support multiple outflows and some more sophisticated options than you have with GEOPAK drainage. GEOPAK drainage was really built around a lot of the Florida DOT drainage workflow for roadways. And it's designed for that, and it's designed to be pretty conservative on its calculations. So we'll go ahead here, and I'm going to just delete the whole 220 folder from eProjects. That's going to be the easiest, cleanest way to do this. And then I'm going to extract our files here for Chapter 5. And you'll want to dig into the zip files so that you're looking at the chapter 5 zip file, but the folder you're copying doesn't have the 5 in parentheses. And we're going to go ahead, I'm going to drag that down here into my E projects. If you don't see the progress bar when it's copying, it's not getting you all the files. So once we have those copied over, we'll have to go through a couple little hoops to get started. We're going to reopen SS4. We'll reopen our drainage project. We'll reopen the preferences for that project. So you'll use the SS4 icon. That's going to give you the settings for Florida DOT. And you're just going to be right back in the DRPRRD01 file. Excuse me. What happened? Oh. We did a few times last week. I have seen quite a few cases where we're unzipping these files. We open the drawing fine, and you go into drainage plans, and just like I did earlier, sometimes when you try and open that drainage project or just open drainage, it'll crash on you. I've seen that pretty consistently. I saw it quite a bit last week, unfortunately. If that does happen to you, just go in that SS4 folder, run clear crash. That's going to shut down everything that's out there and give it another try. And that it'll happen from time to time. It's not going to be every computer all the time, but it will happen, I'm pretty sure, for most of you. Don't like to teach that part, but that's part of it. So I'm going to reopen my DRPRRD01. Now this one, since it's a more completed file, it's going to have the roadway design referenced in. It matches their chapter. It's going to have the topo files referenced in as well. And it's also going to be rotated. So they've rotated the view so that our alignment is running left and right on the screen, just to make it a little bit easier to work with. You'll also see graphically, if nothing else, that we have all of the inlets or nodes put in now. Okay, so you're back in the DRPRRD file, and then you're going to go into your FDOT plans development. You'll open the drainage plans task and click the first icon there to hopefully have GEOPAK drainage open with no issues. And if you'll hit the project menu, it should remember the SR61 GDF file. And hopefully it'll just keep cranking here. Once in a while, if you run clear crash or it locks up, you'll get a message like this. It'll say drainage project, and it'll give the whole path to it. It'll say it's locked by another user. Do you want to delete the lock file and open the project? So I'm getting that message because I showed you how to run clear crash if you needed to. I'll just hit yes, and it should still open the drainage project just fine. Every time we unzip the files, you're going to get this criteria directory warning. Just click OK to it, and that's fine because we're going to open up our preferences anyway. So I'm going to go here to Project Preferences. And from that dialog, I'm going to pick File Open. And I think all of us saved in our eProjects folder that DPF file. If anyone needs that, I've got it on that thumb drive somewhere. Wherever the thumb drive is, I'll find it if you need it. So we'll open the preferences, click OK. It should say the preferences have changed, and we'll click yes to save the changes. And that should be fine now. All right, so if you wanted to take a look at the completed nodes, we can go here to Component, Node Edit. And if you check on Window Center and Highlight, you'll be able to see the various nodes that we have in the project. Now, they're not going to be orange like we had earlier, because when they stored them and when they wrote them into this file, they're just using the drainage standards, which it's all brown. If you were to hit apply on one node, it would probably draw it orange, and you'd have to turn on that miscellaneous 0 level if you wanted to see it again. But as you initially scroll through these, they're going to be just the standard drainage CAD standards. But all the nodes are in there now. If you want to take a look at them, you could. If you're ever looking at a node and you don't know what it is, you can click the first button here, ID the drainage node. Bless you. And then just click on that node and it'll tell you what node it is. I'm getting a few little error messages, so I'll leave well enough alone for now. All right, main point is all the nodes are in the project, but there's nothing connecting them. So what we'll do is we're going to put in we'll just put in one pipe here. Once you've done one, they're pretty much the same. And you'll see that over here on page 511. So we're going to add our pipe. And it'll be the pipe that goes between S200 and S201. They're going to be on the upper side of the road, the left side of the road, around station 702 and 703. Just making sure everything's working here, and we're good. All right, so to add a link here, you're going to go up to your component menu, and you're going to pick link, and you're going to pick add. It's going to default, and it's going to call it pipe-1. That's the same name. They just keep that same name here in the book. We'll click OK. And you'll notice that the link configuration overall at the top, all these, the links, the nodes, the areas, they all have the same look at the top of the dialog box. They all have Window Center and Highlight. They all have ID link. That's these little icons. So they all have ID. They all have add. They all have delete. And then they all have rename. Same setup at the top of all these dialogues. So for your pipe definition here, this is step 3 in the middle of page 511. You can pick the from node and the to node with these pull down arrows. So I can say the from node is S200 and I can say the to node is S201. And then if I hit apply, it's going to go ahead and draw the link in between those two nodes. But what you're going to find out, and this is that insertion point again, you're going to find out that it's going to, there's a little point on the cells here at the curb. So if you took the center and went straight out and hit the curb, that's where the pipe is going to end up being shown graphically. So if you pick it from the pull downs and you just tell it what node to come from and what node to go to, and hit apply, it's probably not going to draw the pipe in the location you really want it to be in. And it's going to give it an incorrect length as well. It probably is not enough to affect the computations if you were designing, but it's definitely not going to look quite right. So that's why we have here in the book steps 4, 5, 6, and 7. If you look at the section that says From Node. Over to the right of that, there's a little tiny icon that says From Node ID. And then to the right of the To Node, there's the same little icon that says To Node ID. And what this is meant to do, when you click these little icons, that's meant to connect up to these. They're kind of hard to see, but it's meant to connect to these little red dots around the structure. And last week, this didn't work really well. I think it'll work better here. So I'm clicking the icon on the From node, and I'm clicking one of these red dots once to highlight it, second time to accept it. Yeah, these computers are much more friendly than District 4 was. They were all like 4 feet off or something. So the idea here with these little icons is to pick the connection point that your actual pipe is going to have in the field. And it's 2 clicks. It is click once near the red dot you want to use, and then click again to accept it, and that should go ahead and update it. So click once, click again. Pretty much have to click on the red dot, and then a second click should connect it. So first click, get as near to the red dots as you can, and second click will accept it and connect the pipe. And you'll see that once you hit apply, when you hit apply is when you're going to see the length update for you. So you probably shouldn't ever use the pull downs other than maybe just to get a start for the pipe. If you use the pull downs, that's going to give you probably the worst location of the pipe using those pull downs. And actually, once you'll find out, I think, is once you've used the little red dots to connect to and hit apply, I don't know that you'll be able to hit the pull downs again and hit apply and get it to revert back to the way it was before. Now, you might be able to get that to happen if you closed out of the link and then went back into it like this and hit apply. Even then, it seems like it's tagged to and stuck to those little red dots, which it really should be. So where this pipe should connect is probably this dot here, and then this dot here. Now the length will not update until you hit apply. You're going to end up with, I get 106 feet even from those 2 dots. If for some reason maybe you can't get the dots to connect, maybe you just absolutely don't like what it drew, there is an option here that says use MicroStation or MS Element ID. So if you had a line that was, I don't know how drastic it'll take this, but if you had a line that was reasonable to use, you can check on use MS Element and then click the ID button, and you can double click on that, and then that will be where it draws the pipe exactly. And yes, I know that's not a reasonable choice. So I'll go back and redo the little dots here. So if you have a MicroStation element, you can force it to use that MicroStation element. Oh, and when you do that, it doesn't want you to set it back.
You have to uncheck the MicroStation.
Oh, thanks. This action will remove and redraw. Yeah, there we go. Thank you. And it's back to a lot better location. So back on our links here, when you will not get the length to update other than graphically until you hit apply. Once you hit apply, it's going to update the length. And you do want to try and have that as correct as you can, because that is going to tie into chapter 13 later. It's going to produce our automated quantities. As far as your pipe type, here at the bottom of page 511, unless it's an existing pipe, the Florida DOT pipes are all going to be circular or elliptical, and they're all going to be concrete. So the only items in the drainage library are circular concrete or elliptical concrete. If it's an existing pipe and you're tying into it, or you're using a different type of pipe, excuse me, this is where you would have gone into the drainage library, went into links, and created a new link that represents that existing type of pipe. Does this make sense? Brand new pipes, Florida DOT, are all circular or elliptical and concrete. Oh, was there slotted drain?
No, override.
Oh,
Override
yeah.
And choose existing pipe.
Yep. So another option for that, thanks, James. There's an override library pay item, and there's a little calculator icon. So that's going to bring up the DNC manager, and under drainage, is it in the root folder? Probably existing features. Existing features, existing pipe, or existing structure. So this could also be used for the nodes. So back on the nodes, even though we did not look at it, there is an option for, at the bottom of the node, override library pay item, and there's an existing structure that you can pick for that. So that's for tying into existing nodes or existing links. That way you don't have to override the library pay item. Or, excuse me, the library. You don't have to edit that drainage library.
That'll also do when you're doing cross sections or plans, it will change the symbology. You update the pay item.
Yeah, it'll be dashed. So what that lets you do both on the nodes and the links is it lets you use symbology that's matching what you want it to, but then it's tagging it as, if you pick the existing feature, it's tagging it as something existing so it shows up right on the plan set. All right, so we don't need to do that, but just thanks for reminding me on that one, James. What we need to do is we need to hit the select button, and we're going to pick, this one is a circular concrete, and then at the top of page 512, it's an 18-inch pipe. And you'll click OK. And as a general rule on all of these dialogues, as you fill out one portion on the left-hand side, I would go ahead and hit apply before moving to the next piece of that dialogue. I think it'll run a little bit better that way. All right, so as far as our pipe is concerned, it's drawn on screen now. It goes between these two nodes that we had previously. And then as we move down the left-hand side here in step number 11 on page 512, oh, excuse me, back on definition here, you're going to toggle on this design barrels option, and you're going to lock it in to use just, actually that doesn't lock it in. You're setting it to one barrel. If you do get into the design portion of GEOPAK drainage, the design size and design barrels check marks those will be your biggest pain, I think, as far as designing. Correct me if I'm wrong on any of this, James, or anyone else, but as you're designing the system, if design size is unchecked, you're locking in, the intent's to lock in that size of that pipe. If you leave design barrels unchecked, it's only going to be one barrel, one pipe total. If you check on design barrels, then whether this is set to 1 or 10, if this is set to 18-inch and 18-inch won't work, it'll try and put in 2, 3, 4. So it'll try and use the pipe that keeps the most maximum depth of cover probably. And that's tied back to the node, the maximum and minimum on the depth. Yeah, so back here on our nodes, and I know we're not doing design, but on elevations, these change from our 0 because they are designing this. So the minimum depth of this is going to be 3 foot up to 20. So that's the envelope James is referring to, from 3 feet down to 20 feet. And this will try and fit in the smallest pipe it can, trying to stay within that envelope. And usually this is a lot smaller. Maybe that's going to be like 3 and maybe a 10. 20 is pretty drastic. Anyway, this ties back to the minimum and maximum depth. And there is a tool, excuse me, that does allow you to lock all the pipe sizes or unlock all the pipe sizes without having to go through it manually when you are designing. Yeah, so this, to link it all together, I'm trying to throw in some extras here if we can. This minimum depth and maximum depth on these nodes, this one here, let's say as James was describing, it's going to use the design surface. If that design surface is 100, the minimum depth for that structure, which wouldn't apply to a curb inlet, but well, it would apply to the bottom. Minimum depth is going to be 100 minus 3 or 97. The maximum depth for the bottom of the structure would be 100 minus that number, 100 minus 20 or 80. And it's going to try and fit the pipes. When it designs them, it's going to try and fit them in between that envelope there.
If you override that in the software, and if the criteria is still working the way it's supposed to, in the criteria when it goes to draw the cross sections, if you violate design, it will be in red. All quotation will be in red.
I don't want to say that. I'm not going to. I was going to change that one.
Having them just put a note out beside it in the same color all the other notes are.
Everybody is.
It's
Okay.
like, no, let's do this in a different color. Let's do this in red.
All right. So for your pipe here, we're not doing the design part. You really don't need to check anything there as far as plan production is concerned. It's still going to be able to draw it in the plan view, profile view, and cross-section view. This is going to be pretty much irrelevant plan production-wise. Conditions, excuse me. If we are plugging this in off of a spreadsheet or some type of tab sheet, we do still need to fill out the correct elevations because this is going to get drawn in a profile view and a cross-section view. So you'll see here in the middle of page 512, step number 12, we have an invert here we're going to check on. So that's at the S200 of 32.9. And you have to check on the checkbox. Invert's going to be 32.9 on the from node. And the to node is going to 31.4. Which should make sense. It's going from the higher elevation to the lower. But you will have to check on these little check boxes in there. And you'll see that, or those values rather, you're going to see them right here in the middle of page 5-12. And you'll hit apply, and then we'll move to the computation portion. Nothing's going to show up there yet. We're not concerned about it anyway because we're not designing. But once this is part of a network, then it would show the computations there for that pipe. So when we get the Chapter 6 files in a little bit here, we'll take a look at a few of them and look at the computed values. I know we're not designing, but at least want to give you a little bit of a little flavor of that. All right, so we'll hit apply, even if I hit it 2 seconds ago. Won't hurt anything. And what we would do is we would just continue with this tab sheet like is shown on page 513, and we would just keep putting in all the other pipes that we have. So I don't think we need to do any more than just the one. And the steps that we went through did start here on 511, and it is entering the pipes just for the plan preparation purposes only. So the whole time we're simulating that we have nothing in GEOPAK drainage and we're plugging it in off of a tab sheet or some type of spreadsheet. Hopefully that won't always be the case, but that may be the case from time to time. All right, we'll go ahead and get restarted here at Chapter 6. We're going to go through 6 and 8. That'll finish up our day today. That might have us done a little bit early, but that was our goal. So for Chapter 6, do as we have been doing, please, and close out of SS4. And then go ahead and delete the entire project that you had on the C drive under E projects, that 220 project there. And then replace it with the Chapter 6 files. And just make sure you dig into Chapter 6 far enough so there's no parentheses or 6 next to that folder. And once again, you should get a little bit of a progress bar as this is copying. If you do get that progress bar, then it did go ahead and probably copy all the files. And then you can go ahead and restart SS4, and then we'll jump through our hoops and get into Chapter 6. So you'll go back into the same file that we've been in, proposed drainage file, DRP-RRD01. And this might be where you would probably start the plans preparation process if someone did do everything in GEOPAK drainage, and they're handing you not a spreadsheet, but they're handing you GEOPAK drainage. And I'm saying it might be where you would start, because probably where you would start would really be Chapter 8. More than likely, if they've went through and they've designed a system in GEOPAK drainage to analyze and look at the network and get pipe sizes and make sure things are working, they would have already had to have built the network here. So you probably would really start in Chapter 8, but maybe they didn't. Maybe they didn't go through and build all the networks. So we'll start here on Chapter 6, and before we do anything in there, we'll reopen from the drainage plans. We'll reopen our drainage project. I know sometimes it's crashing going into drainage or opening that project. So we'll give everyone a moment to make sure it does open and work, and run clear crash if you have to. And then once you do open that project, the zip files will have the criteria warning. Go ahead and click OK to that, and we'll just kind of get everyone here where the project is open and working for you. Because I know it was finicky last week, and I know it's crashed on a couple of you today as well. As we're having people open that project, if you look on page 6.1, you'll see the definition here in the introduction as to what GEOPAK considers a network. It's interconnected nodes and links that go to a single outlet. That's the biggest part of it, is GEOPAK drainage only supports a single outlet per network. We have other programs, and there are other non-Bentley programs that will support more than that. This was very much designed around the roadway process of a set of inlets, a set of pipes, goes out to a pond. If there's more roadway, more inlets, more pipes, goes into another pond. Or it could be the same pond. You know, the pond could have multiple inlets, of course. But the network only has one outlet. And then once you get this drainage project loaded, make sure to go back to your project preferences and reload our preferences file that we've been using. So you're going to pick File from Preferences, Open, and I think all of us did keep that out here in our E-Projects folder or your desktop. Wherever you happen to have kept that file, please go ahead and open up that Preferences file. And we'll click OK. It should ask us if we want to save those changes, and we'll go ahead and hit yes. All right, so we're ready to do Chapter 6 now. If you were inputting items manually off of a spreadsheet, off of some type of printout, you would definitely have to build the network in order to get the plans production process to work. So you definitely would have to do this part. If someone was giving you a GEOPAK drainage database that had already been calculated, you probably would not have to do this part. It would already be done for you. So we're still kind of pretending we're building things from scratch here. The network tool, if you flip over to page 6-3, we're going to skip the adding networks, or we're going to skip page 6.3 because we've already opened up our drainage project. But you will see on 6.3 where they're still going through and opening up the project manager in order to point to the correct GPK file, and we don't need to do that. We haven't been doing that since Chapter 1, and it's been working perfectly fine. Well, not perfectly fine, but reasonably well without doing those steps. So we can take it right here at the top of page 6.4, and we're going to add a new network just like we're adding links and nodes and areas. So we're going to go up to this component menu, and we're going to pick, or excuse me, the network menu, my fault. I'm going to go to network and then add. Now, usually as you're building this and going along, it will pull up that outlet node for you automatically, which it did do here. It pulls up this outlet node S211 out. If there were other outlet nodes, you'd be able to pick them from the pull down and let it build each of the individual networks. If it did not pull up the outlet node, or there were multiple ones and you weren't sure, but you knew where it was graphically, you can click the little tiny icon to the right hand side and then double click on the outlet node, and it would pull that up on your pull down. Generally with the networks, if you are doing the design process, is you would put in all the nodes and all the links for the first part of the project, build the network, then put in nodes and links for the other part of the project, build another network, and keep going however far you needed to. We just have the one network here that we're working with. So the network ID, which is here at the top of page 6.4, step 2, this project is State Road, or SR61, and they're just putting a -1 here. So assuming that we would have other networks, they would all be called SR61-1, 2, 3, 4, just like we have pipe 1, 2, 3, and 4 potentially. So SR61-1, and then the outlet node probably was picked up for you automatically. And we'll go ahead and click OK. All right, so it's going to create a network as far as the name or the object. It has not put anything into the network. Well, actually it has. Now all of these items are in the network. As a general rule, this would be a good time to back up that whole GDF file. And actually, technically, I'm telling you wrong. It has not built the network yet. And there's 4 buttons on here, and the description of these buttons is back on 6.2 and the top of 6.3. There's a validation section that is actually letting you build the network. So the validation, the build network, starts at that outlet and then traces everything back upstream and tries to find all the pieces. So we're going to click this first button here, validation, and it's going to go ahead and build that network. And it should tell you the network SR61-1 is successfully built. There's going to be 14 nodes and 1 less link. So it should have links in the network 13. Total nodes should have an S. Should be 14. You'll click OK, And then once that network is built, next to that icon you just clicked, there's a tool for highlighting the network. So if you click Highlight Network, it's going to highlight the whole network. It does include the areas. So it will include the areas. That may look a little odd to you, but it will include the areas. Now I just turned off a bunch of reference files so the network would highlight and look a little bit better on screen. So it's going to highlight that network. And you can have as many networks as you need to in the project. So at the top of this dialog box, it's built just like those other tools where we have the apply button, we have arrows to scroll back and forth between different networks once we have multiple networks, and we have an icon for ID, or actually add, delete, and then we have an icon for rename, and then there's an icon for set it as the active network. So you're really only working with one network at a time as far as analyzing and looking at items. So that's why you have the ability to activate the different networks. I don't believe it created any shapes, but we'll...
You turned off the DROT.
Yeah, let's see if it did.
The basic boundaries.
Unless it's changed, the only thing that you can't bring.
Yeah, it did create shapes in here, and they're live in the file. Yep. So it is creating, or someone at some time has created live shapes in this file for areas. I did just go in and delete that big one up at the top here. And the question is, or what we're trying to find out, is can we get that area back? So I deleted it. I'm just reopening the project, reopening the preferences. And what James was referring to is there is a component tool, and for nodes and links, there's an option for update all. So I can say node update all, and it's going to go ahead and draw those nodes with that plan symbology I had in my preferences. So I could get them back in the file. Yeah, if I deleted them. I could do the same thing with the link, update all, and they would come back into the file. The question is, will it do that with areas? Well, we'll find out. Area update all, nope, has not been changed.
It will put them in a different symbology, but it will not redraw them into the file.
Yeah, I deleted this one that was up here. It's gone.
Associated with
But I guess it
defined
has
shape.
a area number, but not an area delineation associated.
But
Yeah,
then
so it
how
was
does it know
214.
to re-symbolize the ones that are there?
That's true.
So, yeah.
Now maybe,
It must be linked to the shape.
yeah, that was area S214. I do see it here in the database, I think.
It still has the number.
It's still there, but it doesn't redraw it into the file.
No, not even. I'm hitting apply 5, 6, 8, 10 times.
It knows the.
Yeah.
the
It doesn't break the drainage calculations, but that shape
exactly.
is gone. So since we did sort of prove that there, I don't really need the graphic shape back to get it to work. But a good idea would be select the level that your areas are on, which is typically a drain divide 0, 0, or well, now it's not because I have a different symbology. But you could select the level or levels that your areas are on, and you could do edit and do a lock. That would make it harder to delete items in the file that are in the file. It wouldn't make it impossible, but it would make a mistake less likely. So if I lock these, it's going to lock it. It'll be a lot easier. If I need to unlock them, I can always select that level or select everything again, hit edit, unlock, and then I can delete it, move it, whatever. Yeah, so that was never changed, James. All right, so we built our network. We can highlight the network. Sorry, back to this network dialog here. And then the other two buttons, they're described here on the top of 6-3. And they're under computations. And there's a big difference between the two. The first one is design. That does the hydraulic design of the network, and that is going to size, resize pipes, potentially put in additional barrels, all depending on